All right, this is week 10 practice problems. Let's go ahead and get started. Number one says, what is the surface area of the cylinder shown? Assume it has a top and a bottom base included. All right, so remember, surface area is the amount of stuff on the outside of the shape. So basically, we're going to have to find the area of the top, the area of the bottom, and then the area of this center piece here. So I've kind of shown you the three different things we have to do. The easy part's probably the top and the bottom, right? The radius looks like it's 4. So we know that the area of a circle is given by pi times the radius squared. And so that's going to be pi times 4 squared. That's going to give us 16 pi. So each of these tops and bottoms is going to be 16 pi. So there's my top, 16 pi plus my bottom, 16 pi, and then I'm going to add to it this center piece here. Now what you kind of have to realize here is that if we start to unpack this thing, it's actually, when I start to unfold it, it sort of unfolds into a flat rectangular sheet, okay, once I open that thing up. So it's a rectangle, the height of it is 12. Question is, what's the length? Well, if you fold it back together, you realize it's just the circle that's on top. So basically the circumference of the circle, right, the distance all the way around, is going to give us what, when we unfold, the length of this rectangle. So this is the circumference of the circle. So remember, the circumference is 2 pi r, where r is the radius, and the radius is 4. So 2 times pi times 4, that's going to be 8 pi. So we get the circumference is 8 pi. So 12 times 8 is 96, so we get 96 pi. So all three of these added together, 16 plus 16 plus 96 pi's. When you add those all together, you get 128 pi. So answer choice E is correct, 128 pi. Okay. Question number 2, which figure has both rotational and reflectional symmetry? All right, so A has reflectional. You can see when I fold that in half, it works. But if I rotate it, I have to rotate it all the way around before it gets back. So that doesn't count as rotational symmetry. All right, B looks like it has reflectional, right? You can see down the middle here, it's the same on both sides. But also, if I just rotate it around a little bit, you'll see it's the same star. So that has both rotational and reflectional. C has, well, it looks like it might have reflectional, but it doesn't have rotational. D has rotational. You can spin it halfway around and it'll be the same thing, but it doesn't reflect. And E has neither rotational or reflective. So it's got to be B. It has both rotational and reflective. All right. A square pyramid has an altitude of 4 meters and each side of the base is 6 meters long. What is the volume of the pyramid? All right, so we're looking for the volume of a pyramid. Remember, the volume is going to be the area of the base times the height. And then since it's a pyramid, we're going to divide that all by 3. If it was a prism, we wouldn't divide by 3. So remember, the base here looks like it's a 6 by 6 square. So, you know, side squared is 36. So the area of the base, which is a square, is 36. That's the area of the base times the height. The vertical height there is 4. That's also known as the altitude. And then we divide by 3. So I can see a common factor here. There's a 3 in both the 36 and the bottom. So I can cancel that 3 out. I'm left with 48. So answer choice B, 48 meters cubed is our answer. Notice our answer is in cubic dimensions because it's volume. Volume is 3-dimensional, so that's why we have meters cubed. All right, a square pyramid has an altitude of 4 meters and each side of the base is 6 meters long. What is the lateral area of the pyramid? All right, so lateral area is the area on the side. So we're going to ignore the base here, actually. So we're just looking for the area of the side. Now, if you think about it, the area of the side here is 4 different triangles. There's one on each side of that square base. So really, we just need to find the area of one of the triangles and then add it 4 times, or just multiply by 4. So the hard thing to realize is that right here, we have a triangle. And this hypotenuse is actually the height of this triangle. Okay, you have to kind of visualize that. That triangular side is on its side, and we want to know the distance here, right? We don't know that distance. We know the altitude is 4, and I know the bottom part here is 3 because it's half of the length. So really, I've got this triangle, altitude 3, the base is 4. I don't know this diagonal. We call it the slant height. I don't know that slant height, and I need to know it. Now, if you remember, actually you don't remember because we haven't talked about it yet, but Pythagorean triples, I can use a Pythagorean theorem here, a squared plus b squared equals c squared, and I get 16 plus 9 is c squared. That's 25 is equal to c squared. And you can see that 5 is the only number that squares to be 25. But if I want to solve, I root both sides. I get 5 equals c. So that is what that slanted height is, which really is just the height of this triangle when you kind of lay it flat or lay it vertical. Its height is 5. The base is 6. Remember, that comes from the side length of this triangle. So the area of one of the 4 sides is going to be base times height divided by 2. That makes 30 divided by 2, which is 15. So the area of one of the triangles is 15. Since there's 4 of them, I multiply that by 4. I get a lateral area of 60 square meters. Again, it's meters squared because it's 2-dimensional. Surface area or lateral area is always in 2 dimensions. Talking about a flat object here. All right, there are 2 ponds in a field. Samantha runs around one pond and Tabitha runs around another. The diameter of the pond Samantha runs around is 3 times the diameter of the pond Tabitha runs around. Assuming they run at the same rate, how many laps does Tabitha run for every lap Samantha runs? All right, so it doesn't explicitly say, but it uses the word diameter. So we know we're talking about circles here. It says the one Samantha runs around is 3 times bigger in diameter. So this is 3 times the diameter, where this is the 1 diameter. So it wants to talk about how many laps. So what is that really measuring? The distance around? That's our circumference, right? That's the distance around this pond. So we want to know the circumference formula. The circumference is just pi times d, where d is the diameter. Now notice, d is to the first power. So if I double d, or I triple d, or I quadruple d, it's going to double, triple, or quadruple the circumference as well. So it's going to go at the same rate. So it's 3 times as big of a diameter. That means the circumference is going to be 3 times as big. So when she does 1 lap, that's 3 times as big. Tabitha is going to be able to do 3 laps in the same amount of time, right? Now you could do something like let d equal 5, okay? So Samantha is going to have a radius of 15. That's Samantha. And then Tabitha is going to have a radius of 5, because it's 3 times as big for Samantha's. Then you could plug it into the formula, and you'd get, okay, the circumference for Samantha is going to be 15 pi. And then the circumference for Tabitha is going to be 5 pi. So if Samantha has to run 15 pi, Tabitha is also going to run 15 pi, right? Because they run at the same rate. So in that, she will run 3 times around. So the answer here is going to be C. Tabitha will run 3 laps for every lap that Samantha runs. All right. A completely filled rectangular aquarium is drained of 1/4 of its water before the fish are added. If the dimensions of the aquarium are 52 inches wide, 12 inches deep, and 32 inches tall, then how much water is in the tank in cubic inches? All right, so we know the total is 52 times 12 times 32. That's the total that could fill the tank. But then we remember that we drain 1/4 of it. So 1/4 of that goes away. So if you take out 1/4, how much is left? There was 4/4, right? And you took away 1/4, that leaves you 3/4. So really I want to know what 3/4 of this is. So I do 3/4 of, and of means multiply. So I just basically need to find 3/4 times 52 times 12 times 32. So I do 3/4, okay? That's gonna be 0.75 as a decimal times 52 times 12 times 32. Just type in your calculator. You're gonna get 14,976. And that is answer choice D, okay? All right, line segment XZ is bisected by point Y. If XY is equal to 3x plus 2 and XZ is 12x minus 20, then what is the length of YZ? All right, so I would definitely take the adage of drawing a picture here. Line segment XZ, okay, that's line segment XZ, is bisected by point Y. Remember, bisected means that it makes two equal halves, so two equal parts. And then it says that XY is 3x plus 2. So XY, the distance from here to here, is 3x plus 2. And then it says the whole entire thing is 12x minus 20. All right, well, they don't give us YZ, but because it's bisected, we know it's the same as XY. So really, I can write the same thing here. It's 3x plus 2. Now, all we got to do is realize that the sum of XY and YZ should equal the total of XZ. Okay, so this plus this equals this, right? So 3x plus 2 plus 3x plus 2 equals 12x minus 20. Then all we got to do is solve that equation, okay? This simplifies to be 6x plus 4 equals 12x minus 20. If I subtract 6x from both sides, I'm going to get 4 equals 6x minus 20. Then if I add 20 to both sides, I get that 24 is equal to 6x. Last step would be to divide by 6, and we get that x is equal to 4. Now, 4 is not my answer. What does the question say? What is the length of YZ? Well, YZ is this segment here, okay? And it is 3x plus 2. So 3 times what? Well, 4. We figured out x was 4. So 3 times 4 plus 2, that gives me 12 plus 2. That's going to be 14. So I know answer choice A is correct. All right, now don't forget, when you get to here, remember, you could use your graphing calculator. You could graph the left side, graph the right side, find the intersection. You see they intersected x equals 4, okay, if you weren't sure how to solve that. You could also sort of use guess and check here, right? I mean, you could start with 12 and see if 12 works. So 3 times 12, that's 36, plus 2 is 38. And then that says that this would be 12 times 12, that's 144, minus 20, that's 124. So you see how this should be half of this, and it's not, right? You can actually look at this and say, wait a second, this number is too small. I need a bigger x. And that tells you that 12 didn't work. And you also realize that you need a bigger number. Therefore, it has to be 14. So you can use guess and check here, where you remember you pick B. If B works, then you got it. If B doesn't work and it's too small, then you know it's A. If B works and it's too big, then you go down to D and you guess D, and you can determine whether it's C, D, or E from that guess. So using guess and check would have been a really good strategy on this part as well. All right, an airplane flies 1,605 feet above the ground. A 5-foot person with binoculars can see them by looking up 35 degrees from the ground. How far away is the person from the airplane to the nearest foot? All right, so we've got a 5-foot tall person right here. We've got an airplane that's flying above the ground. Okay, we know that the airplane is 1,605 feet above the ground. Okay, we know it's directly above the ground, which means it makes a right angle with the ground. And the question is, what is the distance from the person? Okay, so one thing you have to realize is that it's 1,605 feet to the ground. This person is viewing with its little binoculars right here, 5 feet off the ground. So really, this distance here is 5 feet, which means that really, in this triangle, this height is only 1,600 feet. Okay, so we're going to deal with that triangle. We know that it's 35 degrees above the ground, right, that they're viewing from. So we have a triangle that we're going to use a trig identity for here. So we know the angle, we know the opposite side, we don't know the adjacent, and actually we don't care, but we want to know the hypotenuse, okay? So what is opposite and hypotenuse, right? Think back to so, ka, toa. Sine is the one that deals with opposite and hypotenuse. So we're going to say the sine of the angle is the opposite side divided by the hypotenuse's length. We know what we know, so we fill it in. 35 is the angle. The opposite, we don't, or we do know it's 1600, and we don't know the hypotenuse. Now remember this trick, if you don't know the bottom, you just switch the bottom and the left side. So I can say that x is just 1600 divided by sine of 35. Now if you're not comfortable with that, just multiply both sides by x. You get x times sine 35 is 1600. Then you divide out the sine. 35. And you get the same thing with the trick. Okay, so really all I got to do is get out my calculator, do 1600 divided by the sine of 35. Also got to make sure I'm in the right mode. Am I in degree mode? Yes, I'm in degree mode. So then I can hit enter here and it's going to give me an accurate answer. 2,789.5, that rounds up to the nearest foot of 2,790. 2,790 is my answer. So I'm going to go with answer choice D. The trick to that problem is realizing that the person's actually 5 feet off the ground, so the way that they're looking is actually 5 feet off the ground, so you have to kind of account for that. That's the only trick to that one. All right, three angles of a scalene triangle are given as follows: 3.5x, 3x, and 1.5x. Find the value of x. All right, scalene just means that none of the angles are the same. All right, we've got an angle here of 1.5x. We've got one here that's 3x and one here that's 3.5x. Well, what do I know about any three angles of a triangle? They add to be 180 degrees. That's how I'm going to generate my formula. So angle 1 plus angle 2 plus angle 3 needs to equal 180 degrees. Here's where I fill in the blanks. 1.5x plus 3x plus 3.5x equals 180. Combine my like terms, since they're all the same variables, I can actually combine all those together. I get 8x equals 180. Last step would be divide out the 8. So 180 divided by 8 is 22.5, and that is the value of x. Remember, you could use guess and check here. You could try plugging in b. You would see that b would give you 3.5 times 22.5. You would have to add that to, well, I guess you would say, yeah, 3 times 22.5, and then you'd have 1.5 times 22.5. If you added all those together, you'd see that that makes 180 degrees. This is a great one for guess and check, because if it's right, you got it. If it's wrong and it's too big, then you know it's A. If it's wrong and it's too small, then you know it's one of these three. And then you just guess the one in the middle. If you get the one in the middle right, then you got it. If the one in the middle is too big, then you know it's C. If it's too small, you know it's E. So this is one where you can tell by plugging in numbers and guessing and checking whether it's too big or too small. That's why it's a great candidate for that guess and check method. Okay. All right, a circle is centered at point B. The line segment AC passes through the center of the circle. There's a smaller circle centered at the midpoint of BC. What is the probability that the point inside the larger circle will come from inside the smaller circle? All right, so this is a probability question. So we need to know the total probability of the entire shape, and then know the smaller probability, and then sort of reason through what that's going to look like. So there's a lot of stuff going on here. It looks like the circle is centered at point B, so that's the center, which tells me that the radius is from B to C. So that's the radius of the big circle. And then it says that the smaller circle is centered at the midpoint. So that means that the center of the small circle is there, which means little r would be half of the radius, right? If it's the midpoint, it's halfway between. So little r is half of big R, okay? That's something that's going to be important here. So big R, we don't even know what it is, but the area of the big circle is going to be pi times big R squared. The area of the little circle is going to be pi times little r squared, okay? And if little r is half as big, then when you compare those, the area is going to be 1/4 of the area of the big circle. Okay, remember how that second power works? It's like half of a half because it happens twice. So I can say that the big circle is whatever it is, and that the little circle is going to be 1/4 of the big circle. So that tells me that there's like 4 of these circles inside there. So if I want to know the probability that a point will come from inside the smaller circle, then I want to know the area of the small circle divided by the area of the big circle. Okay, and the area of the small circle is 1/4 the area of the big circle, and the area of the big circle is just the area of the big circle. So it doesn't actually matter what the area is. These areas are going to cancel and leave you with a probability equal to 1/4. Okay, now an alternate method here would be to actually pick some numbers here, like put it on a coordinate plane and let the radius equal 1 or the radius equal 2. If you did that, maybe the radius of the little one would be 1 and the radius of the big one would be 2. You can see how that would work because it's supposed to be half as big. So when you plug it into the formula, the area of the little circle is going to be pi times 1 squared, which is just pi. Area of the big circle is going to be pi times 2 squared, which is 4 pi. So you can see how the area of the little over the area of the big, those pi's are going to cancel and leave you with 1/4. Doesn't matter what you pick for the radiuses, as long as they're half, it's going to give you 1/4 as your probability. Okay. All right, the following line segment has a length of 156. Find the value of y. All right, so we know from A to B, it's going to be 3x plus 2y. We know from B to C, it's 10y minus 3x. Well, all I know is that the sum of those two should equal the total. Okay, so let's just write that out. 3x plus 2y, when I add that to 10y minus 3x, I should get 156. Okay, now this looks like it's impossible. There's x's and y's. How would this even work? But if you notice, those x's actually cancel out when you combine your like terms. When I combine my y's, I get 12y equals 156. Divide by 12, I get that y is equal to 13. Now answer the question. Are they asking for one of the side lengths, or what are they asking for? They're asking for the value of y. So the value of y is 13. Okay, you don't have to plug it back in to figure it out. Okay. All right, an equilateral triangle has side length of square root of 12. What is its area? All right, if you remember the formula here, we know that it's root 3 over 4 times the side length squared. So all we got to do is plug it in. So the square root of 12 squared, square root of 12 times the square root of 12 is just 12. So I get root 3 over 4 times 12. That cancels here and leaves a 3 behind because 12 over 4 is 3. So 3 times root 3 is 3 root 3. That's how we write 3 times the square root of 3. It's kind of like x. X times 3 is 3x. Root 3 times 3, 3 root 3. Okay, so that's going to be answer choice E. Now, if you forgot this formula, you could draw a picture, okay, and see that this is the square root of 12. If I make a median here, I know that this is square root of 12 divided by 2. I could use Pythagorean theorem to find this height here. Or next week, you're going to learn about special right triangles, and there's an actual quicker way to find that, what this would be. But anyway, we don't even want to mess with that if we don't have to. But you could use Pythagorean theorem, right? A squared plus b squared, that's what we want to know, equals c squared, right? When you square the top, you square the bottom, you get 12 fourths, because the root of 12 squared is 12, and 2 squared is 4, plus b squared equals, and root 12 squared is just 12, okay? That's 3 plus b squared equals 12. So when I subtract the 3 over, I get 9. If b squared equals 9, that means b has to be 3. Okay, So the height there is 3. Well, I could do the base, which is root 12, right? The entire base here is root 12 times the height, which is 3. So base times height divided by 2. That's just the area formula for a triangle, right? Base times height divided by 2. When I do that, I get 3 root 12 divided by 2. Okay? Now, none of our answers look like that, right? But that means there's just some kind of simplification. So if I get my calculator out and I do 3 times root 12, and I hit enter and I divide that by 2, okay, I get this 5.196. So my answer is 5.196, but of course none of my answers look like that. Well, you could, keep trying stuff like square root of 3, that's choice A. You can see, well, it's not A, right? B is 3, well, it's not B, it should be 5.196. C is 2 root 3, so 2 root 3, that's not it, all right? 2 root 5, you can just keep guessing and checking here. 2 root 5 is 4.47, so it's got to be E, 3 times root 3, 5.196, there we go. Now you could do the same thing from the very beginning if you knew your formula was root 3 over 4 times the side length squared. You could just type it in all at once. So root 3 times the side length, which is the square root of 12, and you could square that. Just the side length, right? That's going to do it for you. And then divide it by 4. You're going to get that same thing, right? You didn't have to do a lot of thinking there. And then you'd have to go back through and check all your answers as well, right? Or alternately, if you know how to reduce 3 root 12 over 2, all right? I'm gonna do this in a different color. It's kind of getting convoluted here. 3 root 12 over 2. Well, root 12 is really, when you break down the root, you get 3 times 4. So it's the square root of 3 times the square root of 4. Square root of 4 is just 2. So it's really 2 root 3. So instead of root 12, I'm going to write 2 root 3. That's times another root 3 on top and then 2 on bottom. 2's cancel. The root 3's make a 3. So that's one way that you could do it as well. But I think the easiest way is just to know the formula and then plug it in. And then if you have to check here, sorry, I think I just messed up this green part. Let me go back to this. I had 3 root 12 over 2. I just want to make sure that if anybody was really following this, this didn't make sense what I did. Root 12, okay, simplifies to be root 3 times root 4. And root 4 is just 2. So we say instead of root 12, it's going to be 3 times 2 root 3. This is 2 root 3. Okay? Then we divide that by 2. So the 2's do cancel, and they leave us with 3 root 3. All right, I kind of went through that fast, and I think I made a little mistake, and I just brushed it over, but I want to make sure you see that in case you really want to know how that works. Okay? All right, what is the area in square units of the trapezoid ABCD from the picture below? All right, so we've got a trapezoid. There's 2 ways to do this. I'm going to go through kind of a longer way where I break it up into segments. You can take, an area that's a big thing and break it up into little pieces and realize that it's just the sum of the pieces, right? I've got a triangle here. I need to know the height of this, first of all, okay? So I've got this right triangle with a 3, an x, and a 5. I use Pythagorean theorem here. X squared plus 3 squared equals 5 squared. Next week, you're going to learn the shortcut of knowing the answer without having to do all this work. X squared plus 9 is 25. I take away 9 from both sides. I get that x squared is equal to 16. That means x is 4. If I square root both sides, I realize that x is 4. So the height here is 4. Okay? So when I write this, I'm going to write the height is 4. So now I know the area of that triangle, right? Base is 3, height is 4. So base times height divided by 2, that's 12 over 2, that's 6. So the area of this triangle here is 6. Then I can think of this as 2 different shapes. I can break this up. And if this is 14 and it's 16 from here to here, right? That means this must be 2. So I can do the same logic here. 4 times 2, right? Base times height divided by 2. That's 8 over 2, which is going to give me 4. So the area of this is 4. The area of the middle piece here is just a rectangle. It is 14 wide and 4 high, which gives me 56. So I've got 56, 6, and 4. When I add those all together, I get 66, which is answer choice D, 66. All right. Alternately, okay, I really like this other method better. It's a little less work. All right, is that it's a trapezoid. Now I still have to find this height here, right? I'm still going to use Pythagorean theorem, 3, 5, and find out this is 4. And this is 14, and this is 3, and this is 16. So the base here is 19 total. So the two bases are 14 and 19. So remember, you find the average of the bases. So 19 plus 14 divided by 2, that's the average of the bases. And then you're going to multiply that by the height, which is 4. So 19 plus 14, that's 33 divided by 2 times 4. Number 4 is just 2 times 2. And so we've got a factor of 2 on top and bottom. So 33 times 2, 66, gives me my answer. A little faster, but either way works. You just got to realize that that formula for base 1 plus base 2 divided by 2 times height. That's the area of a trapezoid formula. Okay. All right, what is the radius of a circle that has circumference of 16? All right, so what is the radius? Well, we're talking about circumference, so there's two formulas. Circumference is pi times diameter, or circumference is 2 pi r. It's the same thing, because remember, 2 r's make a diameter. So that's why I get a d here. Okay, now we're talking about the radius. What is the radius? So I probably want to deal with the equation that has the radius in it. It says the circumference is 16, and it asks for the radius. So all I got to do is solve for r. So I'm going to divide by 2 pi on both sides, and I get that the radius is 16 divided by 2 pi. And I don't see that answer on there. It's because there's a common factor of 2. This is really 8 times 2, and there's a 2 down here that I just crossed out. But the 2 and the 2 cancel, leave an 8 on top. So 8 over pi is actually the radius there. You could use guess and check. This would be an all right time to use guess and check. Again, remember, start with B. If it's too small or too big, you can kind of adjust from there. All right, 15, find the perimeter of the given compound figure. All right, so we're asked to find the perimeter. Well, the perimeter is the distance around the outside. So we're looking for this almost like a whistle-shaped object. Well, if I take this and break it up into 2 pieces, right, I could find the perimeter of this piece, and then I could add to it the perimeter of this piece. It's almost like there's 2 different problems here. Okay, I'm just going to add these together. So it's the green perimeter plus orange perimeter. That's going to be our total. Okay, so we'll start with the green. The green is coming from a circle, and I know that the circumference is really what we call the perimeter of a circle. It's given by pi times radius. Oh, excuse me, that's the area. It's given by pi times diameter, or pi times the 2 times pi times the radius. So we know the radius is 5, right? They give that to us. The radius is 5. So we know the circumference is 2 pi times 5, which is really just 10 pi. Circumference is 10 pi. Now we don't have a full circle. You see how we're missing this little section here? We don't have that missing section. So really, what proportion or what fraction of the circle do we have? We have 3/4 of the circumference. So of, remember, means multiply. So 3/4 times the circumference, which is 10 pi. If I simplify, I get 30/4 pi. That 30 divided by 4 makes 7.5 pi. So the green part is 7.5 pi. Okay, now what is the red, or excuse me, the orange? Well, I know that this length is 5. Since the radius here is 5, I know that this length is also 5. And then this length is 5 because of this. And then the radius here has to be the same. So this is also 5. So we have 5, another 5 is 10, 15, and one more 5 is 20. So the total area of the orange is 20. So we add them back together, we get 20 plus 7.5 pi, and answer choice A is correct. Okay. All right, find the area of the shaded region. Note the diameter of the circle is the longest side of the triangle, and the radius of the circle is 12. All right, so what they're saying is that this is the diameter, which looks like it's 24 because of, it's really just 2 of these radiuses, right? It says the radius is 12. That means the diameter is 24. So remember, we're trying to find the area of the shaded region, so we want to find the whole thing, right? And then we're going to subtract away the part that we don't want, the unshaded part. So if this is a circle, we need to know the area. So the area of a circle is pi times the radius squared. If radius is 12, we do 12 squared times pi. 12 squared is 144. So it's 144 pi. Then I want to subtract away the area of the triangle. Okay. Well, the triangle has, remember our formula is base times height divided by 2. I know the base is 24. The height is 12. And then we go. So I just divide that by 2. So I'm going to end up with 144. So really, if I take the outside and I subtract the triangle on the inside, I get 144 pi minus 144. And I look at all my answers and I don't see that there. But I do see a lot of 144s and some pi's. So what's going on here? Well, they factored out a common factor, the greatest common factor. When you pull out this common factor of 144, you got to write what's left over. There's a pi left over, a minus sign, and then what was left over with 144 times 1? There's a 1 left over. Now, how do you check you did that right? If you distribute back in, you would get the same thing that we got here, but you want it in this form. So 144 times pi minus 1, that means the answer choice D is correct. All right, a security camera is attached to the ceiling so that I can watch my cat Whiskers. The height of my ceiling is 10 feet, and my cat is sitting on a box 8 inches off the ground. If the horizontal distance from the camera to my cat is 12 feet, then what is the angle of declination to the nearest tenth of a degree should I position my camera to see my cat? All right, so you can see here that this is 12. It's actually labeled. It's a little hard to see. The cat is 8 inches off the ground. We only know this side. We don't know this side. Do we know the height? I think we do because it's a 10-foot ceiling. And we know the cat is 8 inches off the ground. So 10 feet minus 8 inches will be the height. So let's go ahead and figure that out. When you have feet and inches together, you kind of got to put it all in the same units. So let's put it into inches. 10 feet is 10 times 12. It's 120 inches. If I take away 8, I get 112 inches. So that's 112 inches. And then we want to take this 12 feet and convert it to inches. So we multiply by 12. I get 144 inches there. So now I've got my, my picture here. This is angle theta. This is 112, and this is 144. This is a prime candidate. It's a right triangle because it goes straight down. This is a perfect candidate for those geometrical trig identities. So let's label the picture here. We have the opposite side, we have the hypotenuse, and we have the adjacent side. Remember, it connects the angles together that we know, the 90 degree and the one we're talking about. So which trig formula works with opposite and adjacent, right? Go back to SOHCAHTOA. Right, sine is opposite and hypotenuse. We don't know the hypotenuse. Cosine is adjacent hypotenuse. We don't know. So it's going to be tangent because it deals with the two things that we know, the opposite and the adjacent, and the angle that we want to find. So we set up our formula. The tangent of the angle is the opposite over the adjacent. Okay, there's my formula. Fill in with what you know. The tangent of the angle, which we don't know, is the opposite, 112 over 144. Now remember how to get rid of the tan, you got to do tan inverse. So you take the tan inverse of both sides. Oops. tan inverse of 112 over 144. Tan inverse and tan actually cancel each other out. Leave us with theta. That's going to be tan inverse of 112 over 144. This is right where I bust out my calculator. All right, second tangent, tan inverse of 112 divided by 144. 37.87. 37.87. Remember, we're rounding to the 10th place, so we know it's either an 8 or a 9. It either stays or it jumps. And since it's a 7, it's going to jump. So it's going to be 37.9 degrees. So answer choice A is correct. Now, we could have done this whole problem in feet. We could have left 144 inches as a 12. The only thing is, how would we have gotten the number of feet here? Well, 8 inches is 8/12 of a foot, right? It's 8 out of 12 feet, or 8 inches out of 12 inches. So it's 8/12. That's 2/3. So you could have subtracted 2/3 from the 10 feet and got 9 1/3. So you could have done the tan inverse of 9 1/3 over 12. And you would have still gotten the same answer. Right, if I do tan inverse of, remember how to do the fraction, alpha y equals, and actually number 2 is a mixed fraction. So I can do 9 and 1/3. That's what would be left if I took away 2/3, because that's what 8 inches is. Divided by 12, you still get the same thing. Okay. Make sure you're in degree mode, otherwise that won't be in degrees, it'll be in radians. All right, last problem. Find the volume of the triangular prism. All right, so we've got this triangular base right here. All right, and I want to find the area of this prism. So remember, the area of a prism is always, the volume of a prism. We're not finding the area, we're finding the volume. It's the area of the base times the height, okay? So the area of the base, that's this triangle right here. So I need to find the area of this triangle. So if I just focus in on this triangle, right, it's a right triangle. I know that this little section here is 4. The height here is 5. This long side is 13. I can use Pythagorean theorem to find this. Okay, that's going to give me my base. I know the height is 5. So use 5 squared plus 13 squared equals, that's not right. 13 is my hypotenuse. So 5 squared plus x squared equals 13 squared. 5 squared is 25. I add that to x squared to equal 169. Take away my 25 from both sides. I get x squared is 144. The only number that squares to be 144 is 12. You could also square root both sides and you would get 12. But that means that instead of x here, I've really got a 12. So what is my base? My base is 16. My height is 5. So 1/2 base times height. Well, if I plug this into my calculator, I get 40. That's the area of my base. So the area of the base is 40 times the height. The height is 30. So area of the base 40 times the height 30 gives me 1,200. So that means that answer choice C is correct, 1,200. And that would be in cubic units, but they don't mention the units, so that's okay. All right, that's all I got for today. Appreciate you being here. We'll see you next week.